We continue with the SAMO round 2 junior problems. We go on to problem 11. The question says when you divide 39 by an integer k, then you get a remainder of 4. So what does that mean? It means that when you subtract 4 from 39, you get a multiple of 4. Okay, so therefore 39 minus k, minus 4, which is 35, is a multiple of k. Okay, the same thing, when you divide 81 by the same k, you get a remainder of 4. So you have that 81 minus 4, which is 77, is a multiple of k also. Okay? So therefore, k is a common factor of 35 and 77. Now, there are two common factors. One is 1. It's a trivial one. 1 is a factor of both. And the other is 7. 7 times 5 and 7 times 11. So there are only two common factors. It can't be 1 because you can't. If you divide by 1, you don't get a remainder of 4. So therefore, the answer must be 7. All right. The next question. Okay, so it's the same answer. All right, let's get on to the next question. Question problem 12. Determine the value of z in degrees. So here you have a picture of a quadrilateral. It looks like an envelope. And there's a triangle which is inside there, and you've got three symbols, x, y, and z. Okay, two of those symbols are given, two of the angles, and you got the other two are 2x and 2y. So the angles of the quadrilateral are 2x plus 2y. If you add them up, if you add the angles of a quadrilateral, you'll get 360 degrees. Okay, every quadrilateral, the sum of the angles of the interior angles is 360 degrees. So you can see these two give you 200. If you take it to the other side, you get 2x plus 2y equals 360 minus 200. So that is 160. And which means that x plus y must be 80. So x plus y is 80 degrees. Okay, now that's very nice because you know that x plus y plus z is 180. So those are the angles of the triangle. And these two together give you 80. So therefore, it means that z must be 100. X plus y, we just saw that x plus y is 80 degrees. So z is 100 degrees. So that's the answer to that problem. Okay, and once more, I'll just show you what my written solution is. And there it is. You got it. But you see, it's done very quickly. Okay, let's get on to the next problem, which is problem number 13. So what does problem number 13 says? say. It says that you got 100 sweets are placed in 3 boxes. So, okay, let's just draw these boxes here. You got 100. So altogether, you got 3 boxes. The first and second box together contain 55 sweets. So these two together contain 55 sweets. The second and third box together contain 82 sweets. These two contain 82 sweets. All right, so question is, how many sweets are there in the first box? All right, now you can see this thing is common here. If you remove this thing from 50, you get that amount. So let's give some symbols to this. Let's call this X and Y and Z. So what do you have? You have, oh, actually, you got, oh, this is very easy actually, because there are 100 sweets altogether. So I think they made a mistake with this, because how many are there in the first box? So these two together give you 82. Altogether, you got a 100. So the first box must be 100 minus 82. So that's a very trivial solution. You don't even need the other 50. And let's see if that is the answer. So we say the first box contains 18 sweets. Let's check this thing out. Also, it's 18, but oh, okay, it's the same argument without having to use the 50. All right, so let's get on to the next problem. So we now moved on to problem 14. It's a geometry problem. ABCD is a square. Okay, what does it mean? It means that all the sides are equal and all the angles are equal to 90 degrees, two important properties of a square. And BCE is an equilateral triangle. So you got this BCE, all the sides are equal and all the angles are 60 degrees. And determine the sides of angle AED, angle AED. So this is the angle that we need to get. Okay, angle AED. Okay, let's just use this information to see what we can do here. You see, I'd like to see that AB is a side of the square, and that is equal to BC, but BC is equal to all the sides of the equilateral triangle are equal, which means that you've got an isosceles triangle here, angle ABE. You already know one angle, that is 90 and that is 60. So together, these two angles add up to 150 degrees. So angle B, I'm referring to the entire angle, is 150 degrees. And these two are equal because it's an isosceles triangle. And all three angles add up to 180 degrees. So these two add up to 150 already. So those two angles, they add up to 30 degrees. Right? 2 dots equals 30 degrees. So each one dot must be 15 degrees. I can use x's and y's if I like. I can say 2x, maybe that might be better. Proper mathematics. The 2x is, so therefore x is 15 degrees. So this is 15 degrees. And you'll see the same story here also. Exactly the same thing. We've got 90 and 60 here. So this is also 15 degrees. This x here is 15 degrees. That is 15. This is 15. So you want to know what the question mark is. So if you add up those three angles plus your question mark angle, all three, together they add up to 60 degrees because you've got an equilateral triangle here. All the angles are 60 degrees. So these three pieces add up to 60. Two of them are 15. So therefore your unknown angle is 30 degrees. Right? What added to 30 gives you 60? The answer is 30 degrees. So that's the answer to that problem, 30 degrees. And let's just see if that is what I said. Yeah, you can see the right at the end of this, you've got 30 degrees. All right, so let's just get on to the next problem. So what does the next problem state? Going to problem 15. The bag contains red buttons, blue buttons, and, well, 5, 8, and 11. So you got a mixture, 5 red, I'm going to put an R for red, and 8 blue. These are names. We're not multiplying 5 and R. 8 and 11 green. Might as well make it quite clear. Okay, if you randomly take out buttons out of the bag, I'm going to remove buttons. They all mixed up. What is the smallest number of buttons you need to take from the bag to ensure that you have one of each color? So you want at least one red, one blue, and one green, at least that. Okay. So in a problem like this, you take the worst possible scenario because you say, okay, suppose it doesn't work. So the worst possible scenario is worst scenario. Okay. Um, is where you take the largest number of, is the largest number of removals without getting one of each. See, you want to ensure. You can say, well, I can take two reds out, but you don't know. You put your hand inside the bag, not looking, and no guarantees you're going to take two reds out. Okay. Or you could say, I can take out one red, one blue, one green, right? So the answer is 3. But you don't know whether it can happen. So you need to ensure that you have one of each color. So the worst scenario is where you take the maximum number of bad ones. So you take 11 green and 8 blue, and you still haven't achieved your end, right? But once you take the 11 green and the 8 blue out, then you've got nothing else but reds, but you've got no choice, right? And then after that, you just take a single one, and you have one of each color. So the answer is 11 green plus is 20. 11 plus 8 is 19. And then After that, you can be dead certain that you're going to get one of each color. All right, so the answer is 20. Okay, let's get on to the next problem. But before that, let's just check to see. Oh, there it is. Okay, so the answer is 20. We go on to problem number 16. And it says here that 3 painters take 3 days to paint 3 rooms. How many days will it take 6 painters to paint 6 rooms? Well, you can do this in a couple of... One must be a little bit careful. You have to know what the problem is. So you take 3 painters take 3 days to paint 3 rooms. You might say one painter takes 1 day to paint 1 room. It doesn't work like that. Let's just see now. So if you put these painters in 2 different rooms, you put these 3 painters here, or you want 6 painters, right? So put them in 2 different rooms. You got 6 painters here, and you got 3 here, 3 here. Now these guys, you want to know how many days? These guys will take 3 days to paint 3 rooms. So there are 3 rooms here. And these fellows will also take 3 days to paint 3 rooms. So if you put all of them together, it means you only take 3 days. The answer is 3 days. As you can see, both of them take 3 days. They all start together. So they will take 3 days. And they would have finished painting 6 rooms, right? These 6 people will take 3 days to paint 6 rooms. Now, there is another way of doing this. If you want to say, how long would it take to paint 1 room? And you can decide on that. The 6 painters, if you put them to paint 1 room, 3 of them will take 3 days. So you've got 6. So in 1 day, those 3 painters would have painted only 1 room. In 1 day, the 3 painters would have painted 1 room. So if you had 6 painters, they would paint in 1 day a half a room. See? Three painters will paint in 1 day, they'll paint 1 room. So they need 3 days to paint 3 rooms. So 6 painters, this is a question, 6 painters, they will paint only half a room, because 3 people will take will paint a whole room. 6 people will do it twice the time, half the time. So they'll paint half a room. So therefore, if you got 6 rooms, it will be 6 halves, which is 3 days. All right, that's another way of looking at it. So you can think about that. It's a little bit more tricky. Okay, so we go on. Let's just check to see whether this is. Okay, we use the same argument here. Put the additional three pieces of paper in three rooms. Okay. All right. So we go on to the next problem, which is problem number 17. So what have we got here? We determine the sum of the areas of the two squares shown below. The dotted line has length 12 units. All right. Now these are squares. So how do you find the area of a square? Well, you have to know the side A and the side of the other square. So we need to work out A squared. That's the area of the small square. You need to work out the sum of the areas, you see. So, and you need to work out B squared, which is the area of the large square. And then you need to calculate A squared plus B squared. All right. Now it's given that this dotted line is 12, but you'll see this dotted line is the hypotenuse of a right angled triangle. These are squares which are next to each other, so these are angles are 90 degrees. And this thing here is B because it's the side of the large square, and this is A because it's the side of the small square. And therefore, straight away from Pythagoras, you got that A squared plus B squared is actually, from this diagram here, it'll be equal to 12 squared. That is what you needed to find out. What is A squared plus B squared? So that's the area. They say it's in the length are in units, so you'll have to say square units. And each time you have a volume or area, make sure you put the units. These are square units. All right. So that's an interesting problem. With just one piece of information, the distance between these two lines, these 2 points, you can work out the total area. Okay, so let's just go on to the next problem. Oh, there it is. It is 144. Okay. All right, let's just get to the problem number 18. This jar contains blue balls, red balls, and green balls. So it's similar to the other one which had sweets, I think, in it. The same colors, blue, red, and green. The probability of picking a green ball from the jar is 2 in 5. Let's understand what that means. It means the chances of picking 2 from the jar is 5. That means it means that uh, a green ball will have 2/5 the number of green balls. The symbol is number. Is equal to 2/5 of the total number. We are not told what the total number is. So the number of green balls is 2/5. Then it's only then will you get that the probability of picking a green ball is 2/5. You see. And likewise, the ratio of the red balls to, or the ratio of the red balls to the blue balls is 7:5. So the red balls there are 7/5 of the ratio of the red balls to the blue balls is 7:5. So for every 7 red, there are 5 green balls. Is it? No, it's blue balls. Oh, now they tell you there are 40 green balls in the jar. Okay, so this 40, the 2/5 of the total is equal to 40. So this is 40. That information is given. So if 40 is 2/5 of the total, right, that means that the total must be 2/5 of what is 40? Well, you can see mentally it has to be 100 because 1/5 of 100 is 20. So 2/5 will be 40. But the actual way of calculating it is 2/5. If 2/5 is 40, what is the whole? So you multiply this by, you divide by 2/5. How many 2/5 are there in 40? So 2 goes into that. 20 times 5 is 100. So there are 100 balls altogether. Okay, now for every 7 red balls, there are 5 blue balls. Okay, so there are 100 balls altogether. Of that, 40 are green balls. Therefore, there are, remove the green balls and the blue balls and the red balls, there are 100 minus 40, if you remove that, 60 green, red and green. Why do I keep saying red and green? It's red and blue. Now, for every 7 red balls, there are 5 blue balls. So therefore, it means that you are dividing the 60 in the ratio 7:5. If you divide 60, the ratio or proportion, the ratio 7:5. Okay, so what does that mean? That means you wanted to know how many blue balls there are. So the blue balls is the 5 part. So you get 5/12 of 60. So there are 12 parts altogether. 7:5. Each part is 5. So therefore, there will be 35 and 25. So it's 5/12 of 60. 12 goes into 65 times 25. Well, otherwise, as I said before, you got 12 parts, gives you 60. So each part is 5. So therefore, there will be 35 here and 25 here. Right? So 35:25 is the same as 7:5. 35 over 25 is the same as cancel the 5s, you get 7/5. Right? So you're looking for the fraction. In a way, in some way, you're looking for the fraction. You got 7/5, and you're looking for the fraction. These two must be the same, but they add up to 60 because this is the green and the red and the blue. All right, so the answer is 35. 25, that's the answer. Because you wanted to know the number of blue balls. The red ball, there are more red balls. Red balls to blue balls, 7/5. So it's the 5 part. Okay, so that's the answer. It's slightly tricky, but it's not so bad. That is 25. So let's just Yeah, so I'm doing all kinds of complicated mathematics here, but you can see in the end it's 25. It's not as difficult as I'm making it out to be, but just to put it into mathematical language, you got all these complicated things. All right, let's get on to the next problem, which is you've got this problem number 19. Okay, so you got EFCG is a rectangle. So you got this is a rectangle, the shaded part. Yeah, you can see it's not a square. But inside the square, ABCD is a square. Okay, so that's useful. Right, the point E lies on the diagonal BD. Okay, there's the diagonal, which is BD, such that DE, this part here, is twice EB. So if this is X, then this is 2X. All right. Now, ABCD as area, 81. So the entire area of this is 81. It is a square. So it means that the side times side is 81. So each side is 9. All right. Now, you see, it's quite important to know you got a diagonal of a square here. And these two are equal. This 90 degrees. Right? So these angles are 45 here. And this is also 45. Because the reason is this is an isosceles triangle. The three angles, this angle, and that angle, add up to 180 degrees, right? So these two together will add up to 90 degrees, but they are equal, right? Because it's an isosceles triangle. So that is why these angles are 45 degrees. It's a very important fact that a diagonal of a square, it bisects the opposite angles. They're 45 degrees. Now, if you look a little bit further, you'll see here, this is 45, and in the small triangle, this must also be 45 because you got a right angle triangle there. So this too is 45 like that. So it means that these are equal. So this part is equal to that. So let's call this A and call this B. So this is B. Again, I'm sorry, this is A here. Because you got an isosceles triangle here, you see? 45, 45. So these two are A's. And if and this is also A, opposite sides of a rectangle. So if this part is B here, this is also B. Right? And this is B here because this is also an isosceles triangle. So you see that A plus B is 9. When you add these two, you're going to get 9. Right? And the area of the square is AB, the EFCH. We are looking for what is AB. All right. Now you also have that x squared. You see, this is the hypotenuse of this right angle triangle. So you have a squared plus a squared is equal to x squared. All right, because this you got a right angle triangle, and by Pythagoras, this is the hypotenuse. So x squared is a squared plus a squared. So you got x squared is 2a squared. And here too, you've got a right angle triangle and it's isosceles. So again, you get, but this time the hypotenuse is 2x, so it's 4x squared. When you square that, is equal to 2b squared. So the question is, what is AB? See? Now you also have that 5x squared. Oh, you got that this 9x squared. Oh, I'm spending so much of time over this. This whole diagonal is 3x, you see. So if you look at this triangle here, you'll have 9x squared. This is 3x is equal to 9 squared plus 9 squared. So this is 81 plus 81 is 162. So x squared is 18. Right? So the idea is to find AB. Now I can, when I multiply these two together, I get 4a, 4a squared b squared, multiply these, gives you 4x squared times x squared. But you got x squared is 18. So it's 4 times 18 times 18. All right, so therefore a squared b squared, 4's cancel is 18 times 18. So AB is what we're looking for. Must be 18. Oh, this took a very long time. Well, fortunately, it's been recorded, so you can go over this completely. But it took a long time to get to this. But actually, it's there's a very much easier way to do this, but you must recognize something about ratios, and that is, so the answer we got is 18. Just remember that. If I take out all these things, now this is twice that. We can conclude that this part here, you see, if you look at the small triangle, that one the BEF, and you look at this other bigger triangle, oh, sorry, this is terrible. Okay, if you look at this other bigger triangle, the large one, BDC, you'll see they got the same angles because this is 45, 45, 45, 45, 90. So this is just an enlargement of that one, right? It's like taking a photograph of this large one, you get the small one here. So the proportions should be the same. Right? Photographs always give you the same proportion. If you got a tall man and you take a photograph of him, the photograph will still show you a tall man. It wouldn't show you a fat man or a short man. The proportions are the same. So if this part here is 3 times that, that's what they say here. Or DE is twice this. So this part here must be twice this also. See? So this, look at these two. This is twice that. So this is twice that, but they both add up to 9. So you're going to divide 9 into 2 parts, where one part is twice the other. The only way you can get that is 3 and 6. Right? You're dividing up in the ratio 1:2. And That the whole thing is 9, you see. So now you can use the fact that this is 3 because this is an isosceles triangle. And straight away you've got the area is 18. Right? So this is very much easier. Right? But bearing in mind that the small triangle is just a sort of picture of the large triangle. Very important. These triangles which got the same angles, they got the same angles, are called similar. In grade 11, you do that, but you guys are still junior, so you wouldn't know about similar triangles. But similar triangles are two triangles which have got the same angles. They're not congruent because three angles is not a condition of congruency. But because like what we saw here, these two triangles are not congruent, but they've got the same angles. But there is one important fact about similar triangles that means the blowing one is just a blown up version of the other. All right. So with that long story, we can get on to the next problem. I don't know how I did this thing. Oh, so I did it this way. All right. Okay, I think that probably is the third way of doing it, but I'm not really interested in that right now. So let's get to the next problem, which is problem number 20. There are 25 problems in the second round of the Olympiad, so we've still got some ways to go. Yeah, the time on a clock gets more and more difficult as it goes along. The time on a clock is 12. So let's just draw this clock. Um, I still haven't learned how to move. Oh, there it is. Oh, okay, doesn't do it better. I'm wasting time here. Oh, there we go. Oh, I figured it out. All right. So you got a clock here, and every clock has got a minute hand and a uh, hour hand. So let's just see what he's saying here. How many minutes, after how many minutes will the two hands of the clock make an angle of 66 degrees? All right, so you got a long hand, you got a short hand, you got the angle between them is 66 degrees. All right. And the time currently is 12. So this is the end result. So you're starting off from 12 and you're landing up to this. So let's just get this thing right. Um, if we draw another circle about the same size as this, and I figured out how you're going to do this. And there we go. Okay, it's going to be the same size. All right, so originally it started off as 12 o'clock. So the two lines were at the same place. The hour hand and the minute hand were both together. And that's at 12 o'clock. And then after a certain time, the hour hand moves, right? And the minute hand moves, hour hand moves faster than the minute hand. So you have the minute hand Hour hand is here somewhere maybe, and the minute hand is dragging along. Now, and we know this angle is 66 degrees. Now let's understand what's going on here. You see, the minute hand, it's faster than the hour hand. How much faster? Okay, let's just figure that out. So when the minute hand finishes 60 minutes, moves through 60 minutes, minutes, that's 1 hour. The hour hand moves through only 5 minutes. Then it'll be 1 o'clock, you see. So the hour hand, it just goes through 5 minutes when this minute hand goes through 60 minutes. So that means that the hour hand, HH, or at least let's call it minute hand, MH, is 12 times faster than the hour hand. So for every movement of, if the hour hand, when it moves a certain amount, the minute hand moves 12 times more than that amount. So if we want to know after how many minutes will the two hands make 60 degrees, say, so let the hour hand move to 6 minutes. X minutes. All right, so you got this one here from the vertical. This thing is X. The hour has moved to X. So what does this mean? That means the MH, the minute hand, has moved to 12X. So in other words, this long one has moved through 12X. 12X minutes. All right, so now we can see what the angle between the two will be. So this angle here is 11X minutes. It's a minute. So the angle between them is 11X minutes. So 11X minutes is 66 degrees. So therefore, that's the angle between them. Is therefore X must be 6 minutes. All right, so this X here has moved to 6 minutes, and that's when the angle between these two will be 66. So think very carefully about this. These clock problems can be quite demanding, but the important thing is that the minute hand moves 12 times faster than the hour hand. Always remember that. Right? The minute hand moves 12 times faster. So the angle between them will be always 11x if x is in minutes. And if in degrees, again, it will be 11. If this angle was given in degrees, that too will be 11x degrees. But neither case whether it's minutes or degrees. Get that. So in how many minutes? After how many minutes? It will be after, but it wouldn't be 6 minutes now. X is 6. Oh yeah, X is 6. But you really need uh, X is 6 minutes. So the two hands of the clock make, so 12x, that's the distance the minute hand moved. The answer is 12x. Because they say after how many minutes will the two hands be exactly 60 degrees? So after 72 minutes, so it goes right round and continues for another 12 minutes. All right. So it will actually be 12 minutes past 1. Yeah. It's 72 minutes past 12, which is the same as 12 minutes past 1. But the question is, after how many minutes? 72 minutes. And so one must be careful here. I think I don't know whether I got the right answer here. I might have got the wrong answer. So the answer is after 72 minutes. Oh, so the minute hand has moved through 12 minutes. Oh, no, that is not right. It's actually we moved through 12. 1 minute is 6 degrees, 60 degrees. So there's something wrong here. It's moved through 12 minutes. Okay, no, that is quite right. That is quite right. Because we said 72 minutes, but it's 12 minutes past 1. See? 72 minutes past 12. The minute hand has not moved through 12 minutes, it actually moved through 72 minutes. So this is actually wrong. If the minute hand has moved through only 12 minutes, the angle will be very small. See, from 12 o'clock, if it's only moved through 12 minutes, the angle between them will be very, very small. So the answer is actually 72 minutes. So I'll just correct that. So I must go and correct this answer. It's a little bit tricky. Okay, let's go on to the next problem. The next problem is problem number 21. If x and y are positive integers, what is the smallest possible value of x plus y? And you got that 14x plus 15y is 2023. Hmm. So what is the smallest possible value of x plus y? Okay, so now that's quite tricky. We don't even know what the x and the y is, and this is quite a big number. You can try various numbers, but you want the smallest possible value of x plus y. You can try x equals 1, x equals 2, and so on, but you've got a very big number here. And then you can see whether you can get y are integers, you see. So if I can't put x equal to 1, because then you will have 15y is 2009, and y can't be an integer. 15 times an integer can't be 2009. So the x's have got only certain solutions and y have got certain solutions. We don't know what they are, but they ask for the smallest possible value of x plus y. So let's give a name to x plus y. Let, for instance, z be equal to x plus y. Okay, now we need to know what is the smallest value for z. So that's the question. So if I put x plus y equals z, and I got 14x plus 15y is equal to 2023, right? Then I've got two equations and two unknowns, but I've got a z here also. So I can solve for each one of these, but it'll be in terms of z. And how do I do that? When you got two equations in x and y, you try to get the coefficients to be the same. So here you got x plus y, and to get the coefficient to be the same, you can multiply by 14x right throughout, right? 14x plus 14y. And then you subtract, and the x's goes away. When you subtract these two, you get 15y minus 14y is y. And here you got 2023 minus 14z. Right, now, thing is that y is a positive integer. Okay, so you want this to be a positive integer. And now that tells you you got an equation in inequality in z. So this means that 14z, if you take it to the other side, is less than 2023. And you can solve for z. Let me just put that down, 2023 divided by 14. 7 goes into both of them. 289 over 2, you get 144.5. So z is less than 144.5. So your x plus y must be smaller than that. All right. Now, in the same way, you can work out, instead of multiplying by, we could have written 14x plus 15y equals 2023. Could have multiplied by 15. Multiply z by 15. And this time, you can solve for x. When you subtract that way, you got that x is equal to, take the small one away from the big one, you get z minus, oh, I'm sorry, it's 15z. 15z minus 2023. So you have 15z, sorry, everything is all squashed up here. 15z minus 2023. That's the x. That's your x. And again, you want this to be a positive integer. But this time you have that 15z is greater than 2023. So you got z must be greater than. And you work this thing out, you get 3, I'm doing it mentally, 135 and 8/15. So z is bigger than that. It's an integer. So what is this? You can't let z be equal to that. The smallest integer beyond it is 136. So z is an integer. It's going to be 136 or 137 all the way up to 144 because it's smaller than that. But we want the smallest value for z, and therefore the smallest value for z is 136. So this is an interesting way of calculating this bit without having to actually calculate x and y. All right? If you give a name to x plus y, and you try to work out everything in terms of x plus y. Okay, so that's the answer to that question, 136. I don't know whether that's the correct answer. We'll let's check it out. So if you go into the 135. Oh, well, I think my calculation was wrong. I had 135. Mentally, I was calculating something. So that mental calculation was wrong. Sorry about that. So it's really supposed to be 135 and not 136. Okay. Just as well, I've got my correct answers here. So we can check it out. Okay, let's have a look at the next question, problem number 22. Okay, it's taking a long time because there are so many problems and they're quite difficult. So if you look at this one, in the list A, B, C, D, E, F, each represents a positive integer. The sum of the values of each group of three integers is 25. If A plus E is equal to 9, what is the largest possible value for A? Oh, but if A plus E, they're all non-zero positive integers. So the largest possible value must be A equals 8 and E equals 1. Right? That's the largest possible positive integer, which will make this equation true. Right? 8 and 1. So you can get anything. You can start with 8. They say the sum of the three is 25. So you can put any two numbers here, which add up to 25. You can put anything you like. Put 6 and 19, for instance. And then, oh, wait a minute. The sum of three positive. So if I got 6, I got 8. If I put 6 here, then this has to be 11 because the sum of the three is 25. 6 and 11 is 17, so this will have to be 8. Right? And 11 plus 8 is 9, 19, so this has to be 6. And 8 plus 6 is 14, 11. So these satisfy this condition that we've got. And A equals 8 gives you a solution, so the answer is 8. Because it's the largest possible value. Just from here only you could work out 8, but you need to check to see whether you can get A, B, C, D, E, F, which will have the property that the sum of the values of each group of three consecutive letters. So these are three consecutive letters. You can see the way you're constructed starting from 8. I just put anything here, put 6. I'm going to put something else, right? But A will be the largest. All right. It's not a very clear problem. Let's see whether the answer is 8. Oh, I did all kinds of funny things here. But you see at the end of it, you got 8. But here I had 8, 1, 16. So, oh, I see. E was 1. I couldn't have had 6 there. See, the previous one, I landed up with 6 or something here. But I needed to have E is 1. All right. So that was wrong. So if E is 1, then you can actually get the things. Let me just do that again. Sorry, you got A, B, C, D, E, F. You got that, B, C, D, E is 1, and F. So you want this to be 1. Okay, so the sum of these three is 25. Therefore, the sum of these three is also 25. So these 2 plus 8 is 25. These 2 plus something is 25. So this has to be 8 here. See? And likewise, these three added to 25, so this must be 1. Right? And then you'll get 9 and 16, 16, 8 and 1, 16, and that will give you A plus E is 9. All right, so the fact that E is 1 forces that there to be 1. See? Because these three together add up to 25, those add up to 25, and this is... All right, so let's just get on to the next problem. Okay, it's a good thing I got these answers here. I can always check to see whether I've got the right answers. Let's get on to the next problem, which is this one. Seven matches are needed to build a 1x2 rectangular grid. Okay, if you count the number of matches here, this is 1x2, and there are 7 matches. You've got 3 1s and 2 2s. If you count the verticals. So this is 3 1s, it's 2 2s. And likewise here, how many? Now you got 4 1s here, but actually you've got 4 and 4. You got 8 1s, and you've got how many 3s? You've got 3 3s. 1, 2, 3. These are matches. So this gives you 7. 8 plus 9 is 17. All right, you can see get to 17 there, and likewise you've got 2x3 here, so this is 5 15 1s. This is verticals. The horizontal, you got 4 plus 12. Oh, you got 4 here. You got 12 horizontal, and you got no, you got 16 horizontal and 15 verticals, 5 3s. All right, now you got a 19 by 20 rectangular grid. So how many matches are needed for that? I don't think I have got space for this, but so you got a very large grid here. It's 19 by 20. So let's see now. You got 20 squares here. See, when I had two squares, I had 2 horizontal ones. When I had 3 squares here, I had 3 horizontal ones. So if I've got, this is 20 by, yeah, okay, 19 by 20. So you got, this is 19 here, and you got 20 there. So you do have 20 on each row. So you got 20. How many rows have you got? Now, you got 2 rows. Although you only got 1 here, you got 2 rows. And here you got 3 rows, although you got 2 squares. So this will be 20 rows. See, although it's 19 squares, you got 20 rows. 2 squares will give you 3 rows because the top and the bottom are added. So that is just the horizontal. The vertical matches will be, now you look at how many verticals have you got. Although this is 2 by 3, you got 4 verticals. So you're going to get, this is 21. You got 21, 20 of these horizontal here, the squares, but there will be 21 verticals, and then you have to multiply that by, actually you don't have, it's 20 times 19. You got 20 times 19, there are 19 squares. And here you've got 21. I'm counting the verticals. I got 1, 2, 3, 4, 5 verticals. Although this is 3 by 4, there are 5 verticals. So you're going to have 21 here, the 19. And there'll still be a 19. So you got, and you have to multiply that by the number of rows that you've got here. And this 19 rows. So it's we're counting the vertical columns. So you got 5. So this 20 becomes 21. And you're multiplying that by 3. So it's still 3 by 5. So you got 1, 2, 3, 4, 5. 5 times 3 is 15. So it's 21 times 19. Yeah. So the answer should be 19. 19 is the common factor. 19 into 20 plus 21. 19 times 41 is 779. Okay, so the answer is 779 matches. Let's have a look to see whether that's the correct answer. It's just seeing what happens with these small numbers, and you can see what the pattern is, and you can get the answer to this. Okay, let's just clear out all these diagrams and get to the answer. Oh, this is, I think this is wrong. It's supposed to be. So you have a formula here. Okay, just read this thing. I don't know where I went off. I got 779, but it says in an M by N grid. There's some thing there. All right, just please look at this answer and see whether that argument is correct and decide. I think it works for the formula that we have is 2mn minus m plus n. So that seems to be working. So here you got the formula is 2mn minus m plus n. So you got 2 by 3, it's 2 by 3, and that is 2mn, which is multiply the 2, 2 times 3 is 6 times 2 is 12, minus 3 plus 4. Oh, you had to add m plus n plus 2mn. So it seems that this is the right one here. So you get 39 m plus n plus 760. Okay, that seems to be the right answer. Sorry about that. Okay, now let's just get on to the next problem. Oh, problem number 24. I'll just do this quickly because it's taking too long. Car A and car B are traveling on a straight line. Car A is traveling at a constant speed of 120 kilometers per hour. So let's just take the straight line here. And the first car, uh, car B is behind car B. So you got car B is in the front. So there's B here. And they're both traveling the same direction. Car A is 30 kilometers behind car B. It's 30, but he's traveling at 120 kilometers per hour. And this guy is traveling at 70 kilometers per hour. Okay, so you want to know after how many minutes will he catch up with B? Well, that should be easy enough. In 1 hour, A would have traveled 50 kilometers more than B. So in 1 hour, A covers 50 more than B. But you only want him to cover 30. So how long will it take him to cover 30 kilometers? It'll have to be 3/5 of an hour. It's a proportion problem. And 1 hour is 60 minutes. So that's 36 minutes. Okay, so problem number 24 is not that difficult. It's a problem on ratio and proportion. So let's just see if the answer is 36 minutes. I've been getting a couple of things wrong here. Fortunately, I've got the correct answers. So yeah, it is 36 minutes. Okay, so let's just get on to the last problem. Hopefully, yeah, this is problem number 25. A and B have HCF of 2. That's the highest common factor. An LCM of 30. So A and B are two numbers, obviously positive integers. The HCF equals 2, and the LCM is 30. Okay, so likewise, B and C I've got the HCF of 33, an LCM of 42. So you have to figure out what A plus B plus C is. So you need to know what A, B, and C are. All right. Now there's a very important fact here. I'm sure it can be done easily. So B is a common factor. B occurs in both cases. Okay. So 2 is a factor of B, and 3 is a factor of B also. Because, so 2 and 3 are factors of B. So which numbers have that property? So B will have to be, could be 6, or any multiple of 6. 12, 18, and so on. Right. Then you also have now that B occurs both cases. So the LCM of A and B is 30. So B is a factor of 30. Because the LCM is a multiple of both the numbers. And it's also a factor of, and also of 42. See? Because B occurs here as well. So now what are the, if it's a factor of 30 and 42, it means that B has to be 6 now. 12 is not a factor of both. And so B is 6. And now you can, if B is equal to 6, and so the LCM, the HCF of A and B is 2. So A is a multiple of 2. But not of 3. HCF. And C, and the LCM is 30. So it's a multiple of 2. And the smallest number which divides 6 and A is 30. So A will have to be, A could be 5, or it could be 10. So you'll see A is equal to 10 because the HCF is 6, you see. So because 30 is a multiple of A. So if you can see that A and B, the LCM of these two is 30, and the HCF is 2. All right. And likewise, here you've got, you'll see that C is equal to 21. All right. I was going to say something here, a very important fact. If you use this one here, this works out very quickly. The AB, if you take any two numbers and if you multiply them, it's always equal to the HCF times LCM. It's a very useful fact that the HCF of two numbers multiplied by the LCM of those same two numbers is equal to the product of those two numbers. So that is how I got 21 here, because 6, B is 6, you see. So 6C, B is 6, is equal to the product of the HCF is equal to 3 times 42. So therefore C is equal to 21. And likewise, if you take the first two, AB is equal to 8A, no, 6A. We saw the B was 6. 6A, and that is the same as 2 times 30, which is 60. So you can see 6A is 60, so A is 10. You did it like this, then you don't have to guess. Okay, so you got A is 10, and C is 21, and B is 6. So when you add the three numbers up, you'll get 10 plus 6 is 16 plus 21 is 37. And that is the answer to the last question. I'm sure this is the correct answer. And there you got it. You got it, 37. All right, so I state the same fact, which makes the problem very much easier to calculate. Okay, this has been a long session. Thank you very much for listening, and enjoy the rest of the day.